Okay, we're going to talk probability, and we're specifically going to talk about two words, and or. Think about it. If somebody offers you cake or ice cream, it only means you're getting one of them. If they offer you cake and ice cream, it means that you can get them both. So make sure you understand the difference between those two words. Now, the probabilities that we're going to talk about is we're going to talk about a spinner that has a 1, 2, and a 3 on it, and a die, a six-sided die. I'll just make it the number 4 on it right now. And we're going to have two questions. And the only difference is that we're going to change out the and the or. So question number 1 is going to be, what is the probability that's such a long word, of spinning a 2 and rolling a 4. So there's that key word there, and. The other question is going to be the exact same thing, but this time we're going to spin a 2 or roll a 4. Okay, and this is a difference. A big difference. So the top one is saying that both events have to happen together. That's kind of like saying, what's the probability of getting hit by lightning and having it on your birthday? So it's going to make the probability even smaller because both events have to happen at the same time. The bottom one says, hey, we can have a spin of 2 and we don't care what's on the die, or we can have a roll of 4 and we don't care what happens on the spinner. So it actually makes it very, very easy, or easier, to get the probabilities anytime that there's an or. So the top one, the and, should actually be a very small probability. The or should be a greater probability. So we're going to take a look at this one up top first, and we're going to say, okay, the probability of spinning a 2 is there's one number 2 out of 3 possibilities. And on the die, rolling a 4, there's only one number 4 out of 6 possibilities. So those are the probabilities there. So we're going to take that 1/3 and the 1/6, and in the case of an and, we need to multiply them. If we're multiplying fractions, we're actually making it smaller because we're taking 1/6 of a 1/3. So if somebody says you're going to get 1/6 of 1/3 of a pizza, you're not getting a whole lot. In fact, if we multiply straight across like we do for fractions, we end up with 1/18. Now, this is actually the answer, except something you have to understand is that all probabilities are a decimal between 0 and 1, including 0 and 1. And so you could put this into your calculator, 1 divided by 18, and it would come up with a decimal close to 0.06 or something like that. And so it should be pretty easy. The bottom one, it's the same probabilities, 1/3 and 1/6, except this time we're actually going to try to give ourselves a better chance because we only need one of these to happen. And this is where we add. And if you use your calculator, it makes it really, really easy. But if you don't use your calculator, then we got to go common denominators and such. There's also what they call a smiley face technique. It's a little action like this. And so we go 6 times 1 is 6. And we put a plus sign, and then another one. 3 times 1 is 3, and then 6 times 3 on the bottom, that's the smile, is 18. Now we've got common denominators, so we add them together, equals 9/18. And you take the 9/18, reduce it. Oh, that's 1/2. Is there a little problem with that? I think that's right. It's kind of amazing how that works. So I actually really like the smiley face technique just because it is pretty easy, as long as you're comfortable with reducing. So the difference between these two, even though we're talking exactly the same events, it's only a 1/18th chance of having both events happen together. Whereas if we only have to have one of the events happening, the spin of 2 or the roll of 4, it's a zero point 0.5 or a 1/2 chance of that happening. Kind of interesting how that works out. All right, see you in class.